This video is going to have two more examples from chapter 3.8, which is on implicit differentiation. These problems come from your calculus book on page 317. So let's begin. If you notice on the left here, the 3x cubed is just a general question or a general derivative where we're going to use our power rule to bring the 3 down. And so it's 3 times the 3 that's existing there. The x to the 3 minus 2. The right-hand side will be a similar thing. However, this part here, this will involve a product rule. So let's do that part now. I'll put that in brackets so you can see that part. All right, product rule involves the first. I'm going to make 9x my first part and y squared the second. The derivative of the second is 2y. And then y prime is the derivative of y. So that's our chain rule involved with that. And then plus the second, which is y squared, times the derivative of the first. The derivative of 9x is just 9. And that's our product rule. We'll clean that up in a second. This side, same as the first part. So this is going to be 3 times 5, and then x to the 3 minus 2. So this is the derivative now. Our objective here is to get y prime by itself. So let's do some cleanup first. This is 9. Excuse me. These should be 1s, not 2s. 3 minus 1, 3 minus 1, and that should be x squared. This is 18x y prime plus 9y squared equals 15x squared. All right, so now I'm going to move everything that doesn't have the y prime over to the right-hand side. So 18. We've got our 15x squared. Then I'm going to subtract the other two things. So subtract 9x squared and subtract 9y squared. And now we divide by everything that's not y prime on the left, everything that's in front of it. So we're going to divide by 18xy. Over that 18x times y. And we've now solved for y prime, and we're done. We don't know what y is. Y could be anything. So we don't worry about that. Let's go down. I've got one more problem. The next problem in the book, problem number 304, the same page. All right, so we've got three things to take the derivative of. The first one's xy. That's going to involve a product rule. I'll do that in brackets again. So we have the first times the derivative of y is y prime, plus the second, which is y, times the derivative of x is just 1. And I'll write it there just to show you. We'll get rid of it in a minute. All right, and then this next part, I'm going to put the negative there. We're going to have to remember to distribute that after we're done. And we're going to have the derivative of cosine is negative sine of everything. But then we have a chain rule, so we have to multiply this by the derivative of x times y, which we note is actually over here again. Not in that, yeah, so it's the same order. So I will x y prime plus y times 1. And the negatives are going to cancel and make a positive, so we're good there. And this all equals the derivative of 1 is 0 because the derivative of any constant is 0. So I'm going to move what I've underlined there over to the other side. So I'm left with just sine of xy, and this is a positive because we have two negatives here that multiply to give us a positive. And then we have the x y prime plus y. Hold on a second. No, what I'm going to need to do is I'm going to need to factor out the y prime. So let's start that over. The xy prime for that matter. All right, so I've got an xy prime here, and I've got an xy prime here. So I've got an x and a y prime. Let's move this y over to the right, so it's going to be negative y. This is going to have to be multiplied together, so it's going to be plus sine of xy times xy prime. Now, we've got to distribute the sine of xy with both of these, so we're left with a positive sine of xy plus y, which we're going to move over to the right. So it's going to be a minus sine of xy times y, which I'll move in the front of that. It's minus y times that. Okay, so now we can factor out a y prime from the left-hand side. I mean, I can factor out a y there, but that doesn't look like it's going to matter, so I'm just going to leave it alone. Maybe we'll do it later if it looks like it does. All right, now we're going to divide by this guy here, x plus sine of xy, to leave our y prime alone. And there's no way we're going to be able to cancel the numerator and the denominator, even if we factor out a y or a negative y or anything like that, because we're going to have 1 plus sine of xy over x plus sine of xy with the multiplier. So there's no way to cancel anything. So that looks pretty good and looks like we're done. All right, well, that's two more examples from 3.8.